Hey everybody, it's Nick. Today's tutorial is about numbers and points in computational design. And we're going to be looking at the different ways that we use numbers in Grasshopper, like how we make numbers and change numbers, and then how we convert those to points. And that's a really simple way to start building like computational form and kind of understanding some more of the principles of computation. And just to kind of get things going, where we're going to end up today is, we're going to be deriving kind of mathematical surfaces um, from numbers to create points, and then we can take that surface back into our canopy script that we had before and do some pretty cool stuff. So that's kind of where we're going to end up today. So there are lots of different ways to make numbers in Grasshopper, and I'm going to take you through some of the basic methods. And some of these you might remember from some of the other videos, but I just want to make these methods really clear. So the most basic way is just simply to make a number component. And anytime you have one of these black components here that are found under like the parameters tab, these are just kind of like containers for different kinds of data. And the numbers component just lets you put in a number or like multiple numbers. And one of the things I see students doing pretty frequently is that they'll change the label for the number. So they'll say like, oh, 50. Um, but that doesn't actually give you any data. You can see it's orange. There's no data. That's just the label. In order to get it to actually store a number, you've got to type in the number here under set number. So I could call that 50. And then I can copy that and I could change that number, to say like 100. And then if I, take a point object, I'm going to say construct point. Can plug that in for the X and the Y. Let's zoom out here. And I've got a point. Oops, plug that in for X and Y. Let me turn the grid on. There you go. So now I've got a point that's at 50, 100, and I can flip those around. So I've got like a parametric point, basically. Um, and that's, it is parametric, but these are just constants, right? They're not like if you had a number slider and you could actually change that variable. So if I go make a number, well, I've shown you guys this method before. I mean, I can make a number slider by typing in a number, right? I can also make a number slider by typing in a range of numbers. So if I wanted to start at 1, I could go 1 less than, um, 50 less than 100. And that's going to give me a number slider that starts at 1, is set to 50, and goes to 100. And that's a really quick way to make it, rather than like making a number slider. Oops. Making a number slider and then right clicking it and then going to edit and then typing in 1 and then typing in 100. Whoop, I already made a mistake there. And all that sort of thing. You can see that the first method's a little bit faster. So in the language of computation, right, these are constants, like these are these kinds of numbers here, and this is a variable. So if I would plug in this number, I can affect that coordinate. Of course, I could copy paste these. I have a lot of variability, right, with that for that one point. And this is the simplest kind of structure, right? If you would just have this construct point object, you can take a number and turn it into a point, right? And just that's the most basic kind of construction. So we've got number components, number sliders. The other thing that's very important is the panel component, and this is extremely versatile. You can find it just by typing in panel. Panel component works similar to a number component where you could double click it and I could type in some number and then I can plug it in and that functions as a number. And what's nice about this is if you've got icons on, see the thing is that's different too is if you have the draw icons like display on, which I like to use a lot just because it makes these a little bit more visually clear. If you have draw icons on, then you don't even see the labels for these numbers. And that can be kind of a hassle, right? So now well, this is a problem. See, I've labeled this as 50, but the number is actually 100, right? That is a big problem, right? Um, but that's why you're not seeing that. Okay, so be careful of that too. This is why I prefer to use panels though, because if you have a panel and you type in the number into it, it's kind of a label and it tells you what the number is at the same time. Like that's 75, and that operates as the number 75. And that's something you think about all the time in computation is like clarity, is because a lot of times computation's invisible, or the information's not like readily at hand. And so you want to be thinking about like the ways to visualize what you're doing, uh, and ways to visualize things for others. Like if I gave you a script and it had all these things in here, you wouldn't even know what these numbers are unless I took the trouble to label them or took the trouble to put tags on them or something like that. So um, be careful about that. Like that's how you can get into trouble or get somebody else into trouble. So the panel component's really nice as a way to represent a number, and it's easy to change. Just double click it and just type in a number, and that works. What's kind of neat about the panel component too that we'll see like later on, we'll use it later on, is that it also serves, so you see it has input and output. When it's input, you can type in a number and put it in. You can also take any output and you can actually express it. So now I can see that there's a point here that's at 100, 100, 0, or a point that's at 150, 0. And that's extremely useful. Otherwise, you have to hover over and it takes a second, right? But the panel's always there. And of course, the panel's dynamic. Like it's going to update like automatically. And you can leave those panels in your script. Like they don't really cost you anything. It's just a really nice way to see what's actually happening inside of your script, you know. So that's pretty cool. We're gonna go ahead and start again. So by default, your point objects are always going to be at 0, 0, 0. The other really important thing, really important way to generate numbers is through a component called series. And we use these a lot. This is this really powerful computational idea of a loop. And the way that this works by default is that you have a starting number 0, a step size, so what the difference is each time you increment, and then the number of times you want to increment something in the series. So it's basically a list of numbers, and that's extremely powerful. So if I go in, I'm going to make a number slider again. I'm going to just make it 10 to 20 here. Oops, didn't finish that. Got to press enter in order for that to work. All right. So step number start. Something to think about too with computation. You be very careful about this if you're not used to it. I'm gonna get rid of that. Well, I'm gonna stash it there for now. Something to think about with computation is that it often starts at 0. Remember, we're thinking about binary, we're thinking about computers. Humans, of course, like to start counting by 1. It's a big difference between starting from 0 and starting from 1. Some things can't tolerate having 0 as input. For example, you can't scale something by 0, right? That'll mean there's no object. So just be careful of that. That's kind of why when I make my sliders for a series component, I like to think about starting with 1. That way I don't run into that mistake. So right away, so you can see how this operates here. I'm starting at 1, stepping by 10, and I'm gonna do it 10 times. But look here, see even the way the data is inside the panel component starts at 0. So the first one is called 0 and it's 1. The second one is called 1 all the way to 9. So even though we have 10 things, we start at 0 and count to 9. Okay, so you can see, if you kind of play with this, you can see like how you get all the different values for things. Now, when that gets interesting is when you start to use it for points. So I can take that list of numbers and plug it in for the x component. And now I can, let's say I've got 10, then I'm going to count by 5. Right. So that's my list of these things. And that's like a really quick way to get points. And I can put that into the, x and the y. I can just put that into the y. And that's gonna be a way that I could generate, columns and rows like in a really quick manner, right? Um, and in fact, like this is so there's that. So there's a series. The next thing I'm going to show you is another component that's called range, and this is equally important. So this range gives me a range of numbers, and range works differently. You have to be careful of the difference. So it takes a domain, which you've seen before in the previous service example. So it's starting at a number, going to some other number, and then how many steps within that. And go ahead and make a new panel. Yeah, I'll just copy this one. Remember, make copies. That's one of the computational strategies. I should have thought about that. So copy paste, and then I'll plug this in. And so here's what's happening. When you have like the domain is 0 to 1, and the number of steps is 10. And what you have to watch out for with a range is that even though I said it has 10 steps, you can see it counts at 0 to 10. So how many objects do you end up with? 11. And if you're expecting 10, that's going to be one more that you have to deal with. So sometimes you have to think about changing that, either making it 9 steps or putting some math in and always making sure that it's like subtracting 1, or changing the results at the end. And we'll talk about this later, but just be aware of that. Like the way that counts is very important. Okay, so in order to control this a little bit more, we're going to put a construct domain component in. And there's all kinds of ways in Grasshopper to create objects. A lot of times you're looking for the word construct. So like construct point, right? Construct domain. Okay, so just be aware of that. It's just one of the things that just one of the ways that they name things. So here's the construct domain component. You can plug that in. Now the way that this operates is that you basically take a number slider, and I'll just go ahead and copy these here. Number slider for the first number, domain start, and then a number slider for the second number. I'll move this over so you can see this a little bit better. Right now there's nothing happening. Okay, so here we've got between 1 to 20. Okay, and then another number slider for the number of things. So go back to 10 again. So it's like that's a quick way. Now if we go by 9, so it's dividing 1 to 20 in 10 steps. If we go back to a domain of 10, dividing it by 9 steps, you can see that we get pretty much a count here. But that can be really handy, because I don't know about you, but I'm personally, can't keep all this stuff in my head when I'm trying to divide stuff out, but this is a quick way to get what you need. So if you know where you're starting, and like what the steps are, and like how many things you want, right? Like a series works really well, right? It's just going to give you those numbers in like a sequence. If you know where you're going to start and you know where you're going to end, then range is going to help you divide that up into things. And so these are two different ways of getting lists of numbers, and of creating sort of like repetition. And that's a really important idea, and a really strong computational idea. So let's see what that looks like in practice here. So I'm going to go ahead and start with our point that we made. And I'm going to leave this panel up just so you can kind of see what's going on here. So starting with the panel, I'm actually interested in making a line. or at least making a series of points. I haven't made a line, making a series of points in the x-axis. So got to make like a maybe 20 points or whatever, spaced by 5, starting at 1. And if I wanted to start at the origin, like it'd be pretty easy to go back and change that. One thing, just to refresh your memory, if you haven't looked at this in a while, right now I'm looking at integer numbers. These are whole numbers. They're not fractions. If I wanted fractions, I could just go ahead and change the type to floating point numbers, and then I would get decimals. You can also limit to even or odd numbers, and that's useful in different contexts. But just so you know, like that's what I've been working with is whole numbers. But I can certainly get fractions or decimals. So I've got these points made. What I'm going to do though is I'm going to turn these into a grid. So it's just taking numbers and turning them into points, and now I'm going to start to get a form by basically plugging in. If I take this list of points, list of numbers, sorry, I can plug them in for y. And what do I get? You can see that I get, the same number in both, which makes sense. I'm going to get this kind of ladder. Okay. Now, one of the things we've been doing in some of the other videos, and I haven't really covered, and I'm going to keep covering it, but I'll start talking about it right now, is this idea of grafting. This idea of grafting a data structure. Remember, to graft something, we're going to right-click it and go to graft and say, okay, so now what we've done is we've created a grid. Well, how have we created a grid? So if you look, and I'm actually going to shrink the points just so I can show you this better. We can turn it back on again. There we go. So very clear, like in the x coordinate, we're going to keep increasing our number, 1, 6, 11. Actually, let me go back to 0. There we go. Make this cleaner. Okay, so 0, 5, 10, 15, 20, all the way up to 45. Okay. Remember, if I don't graph this, that's what we're going to get. If I graphed it, so now you can see that the structure is kind of changed up here. This is the kind of data index, just a way to represent that structure. You can see though that I've got these kind of bars here. These are kind of data containers. You can think of them as like boxes or egg cartons or packs of gum or whatever, but each row, when I graph these in the Y here, gets kind of contained, right? So I now have a row that's just 0 to 45, but 0 Y. And then I've got a row that's all these on 5, and then a row that's 10, and a row that's 20. And that's how we get the grid, right? We go from 10 numbers, right? We've got 10 to 100, 10 by 10. Okay. So what grafting is saying, like, instead of just operating on these pairs, I want you to group these into Y, and then I want you to apply the X to each one of these containers, right? So I've got 10 kind of Y containers, each one repeating this value with the X coordinate, and that's what's going to give us this grid. Okay. We'll go back to this, and we'll continue to go back to this. Data structures are one of the most difficult things to understand, but just for now, just understand the difference between having this grafted, and having this not grafted, and that's what we're gonna start with today. We're gonna start with that grid. Okay. So then the next thing we're gonna do is we've got this set of points here, all right? And I'm looking at this in top view. Just want to be clear about what that looks like. So now I've got my grid, and I can change that grid parametrically. You can change the scale of it. You can even move it if I want to. Okay, but anyway, it's just numbers. So numbers to points. Next thing I'm going to do is add a GraphMapper, and we've seen these before, in a previous video, and I realize a lot of this is still kind of review for you guys. The GraphMapper is another way of creating numbers, or if I want to be more accurate, of manipulating numbers. And the way the GraphMapper works is that it takes some range of numbers, which is great because we have a range here, and I'm going to turn it on just by going to graph types And I'm going to go ahead and just add a sign. We'll look at this a little bit more later, but plug it in so we can see what's happening here. Okay, so the way that this works is you can say that like the first number belongs here, and then the second number in the graph mapper belongs here, and then the divisions get kind of put into it, and then they get intersected with what's happening in the graph mapper. Remember, like in high school, where you're like plotting something, and so it's a way of basically changing that. And actually, the way that I'm going to use these is I'm just going to simply have it be the domain of 0 to the domain of 1. Now you can see these lines here, these red lines. Again, where that red line intersects this curve, it's going to return a value. And you can see if I ask it for so and so many numbers. Well, let's actually look at something that's a little bit easier to understand. So if I just do a linear, there's a line here. Very easy. So from 0 to 1, you can see where it intersects. It intersects at 0.2, 0.4, 0.6, 0.8. And if I change that, that's what I'm going to get. So they're all at a quarter. And it's just a quick graphical way of defining relationships to things, whether it's linear or parabolic or conic. And there's different things, like there's noise, which is kind of like pseudo-random, Perlin noise. Okay. And you can play with those. I'm going to go ahead and do a simple sine curve for now. Sine curves are really great because they go up and down, they go in and out, and that's something we can exploit a lot in architecture. A lot of variation, happens that way. They're very smooth because they're periodic, they're based on circles. So that's something that we can exploit like quite a bit, and we'll see some examples of that. What am I going to do with that? I'm going to change the points in the z-axis. So I've got a grid, and then basically I'm going to use these numbers to basically draw this. I'm gonna translate these numbers to these points. These numbers are very small. In fact, 0 is really small. And in fact, I'm gonna go ahead. Nah, that'll work. That's fine. 0 works in this case. I might have added maybe a 0.1 or something there, but it's not gonna hurt anybody today. What I'm gonna do is make these numbers bigger, and an easy way to do that is just to multiply. And remember, you've got all these operators that you can use. You've got multiplication, you've got addition, subtraction, and it's, yeah, subtraction, division. It's an easy way to parametrically, change numbers. So what I'm going to do is I'm going to plug in these numbers, and I could plug them in from here too if I wanted. And I'm going to make a number slider. A number slider is going to be probably, let's just call it 30. Plug this in. So now there's a bigger, you can see though as a sign it goes up to 23, down to 14, down to 3, up to 28, to 4. So that's nice. The problem is that I really need these numbers to match these numbers. So right now I've got 12, and I would ask you, what do you need to make this to make this? These numbers have to agree. I need an x coordinate for each one of the rows. Okay, so what would that be? Well, I could go ahead and plug in the same slider, and I'm going to go ahead and plug this all in. So hang on a second here. Let's go ahead and clean this up a little bit. Okay, so I've got my numbers. Go ahead and plug those in for the z. And you can see that I've got this kind of wavy thing. To make this a little bit more clear, I'm going to go ahead and just make a curve, NURBS curve. We'll talk about NURBS in a bit. Go ahead and plug that in. Now I can see these curves. But I've actually got 14 values, and I've got 13 values here. And that's actually going to create like an additional row. Just trust me. So what I'm going to do is I'm going to take this, and I'm going to add an expression. And an expression is a way of putting some math into a component. We saw this in the very first tutorial that I ever gave you for Grasshopper. You got to be careful with them because it can kind of hide things from the user. But sometimes you don't need to worry about it. Like you don't want to be bothered with it, and you don't want to bother anybody else with it. And so if you know what you're doing, you can go ahead and make an expression. And the expression I'm going to do is I'm just going to say x minus 1 because I know that because of the way this thing starts, it's going to always add an additional number because it counts from 0. And so now I've got 13 numbers and 13 numbers, and that's right. And if I adjust this, they're going to match. And that's what I'm really looking for. A lot of times in Grasshopper, a lot of your problems are caused by the number of values you have not matching or the data structure not matching, and we'll see that a lot more like in the class. So what have we done? We've got this series of coordinates, 196 coordinates. Let's make it something easy like 100. There you go. Yeah, nice 100 coordinates there, which actually ends up being 10 lines. Now you can see these like dashed lines. What that means is that data is grouped. That means that data is grafted. It's in some kind of a structure. Okay. And to ungraft something, right, we're going to flatten something. You can see if I look at this, I'm getting 10 groups of 10. But what if I want to consider these, curves, right? I want 10 curves. Well, you can go ahead and flatten that data. And now it's just 10 curves. That's very clear. They're not grouped anymore. And in fact, if I go in on the loft those together, 10 curves become one surface. So now I've got a basic surface. And so now I can change, this is kind of changing like the amplitude, this like multiplication. I can change what that looks like here, like graphically. There's all kinds of different things that you can do, to adjust that. So kind of a quiz that I would give you, right? Something to kind of to think about things at this point would be, what if I wanted to make this surface vertical? Like, how would I do that? Um, so for example, if I was actually gonna do that, how would I change the connections in the point component to make that vertical? Okay. So to start with, how would I make a grid that goes this way? And then where would I plug in the multiplication component from my GraphMapper to make it look like that? And that's so I can start to do designs like this, right? So just think about that for a minute. Like what would be what you would have to do to get it to do that? Okay. So the next thing I'm going to do is I'm gonna make this a little bit more complicated in a fun way. So go to the sign, and again, I think this is review for some of you guys, but I just want to make sure you understand this conversion from numbers to points. So I'm gonna make another GraphMapper, and remember what we're doing right now is we have a grid in the x and the y, and then we're affecting the z, like we're kind of giving it like elevation. What if we want to make the data three-dimensional? Like what if we want to make the data a little bit more like complicated? So having like rows and columns of that data, and like combining the sine waves together, for example. So the way to combine things, right, is going to be with addition. And actually, before I do that, I'm going to go ahead and copy this multiplication structure, plug this in for A. I could give it its own slider, but I'm just going to try to keep things simple. So once again, I've just got the same GraphMapper arrangement with construct domain, range, And then I've got my data, so I'm going to take addition, plug this in, plug that in. But I've still only got 10 numbers. What I want is I want 100 numbers. I want to look at this data three-dimensionally so that there's rows and columns. So how would I do that? Right? What did we do up here when we wanted to go from simple structure to three-dimensional structure, right? We grafted it. So what do we do? What do we do here to make this number? So to go from 10 numbers, right? Look at this to 100 numbers. Think about that for a minute. Okay, so yeah, the way we do it is we're going to graft one of these. Now we got 100 numbers. What's that going to look like? Well, let's find out. So plug that in for Z. Now we're talking. That's pretty cool, right? So now we've got a much more complicated visual structure. You can really start to play with things. One thing you can do to kind of help things is just throw a preview object. It defaults to kind of candy, uh, kind of like a cotton candy color. You could just make a color, actually swatch, and it's color because they're British, which is kind of funny. Let's see here. I'll do that. There we go. Let's change that hue. I don't know. You can make whatever color you want, but there you go. Makes things a little bit more clear. But you can spend all day going through these different types and kind of experimenting with what the different combinations of these things like looks like. It's kind of fun. And this is where we end up with the example that I gave you guys before. And something I kind of want you to think about is like, okay, so if I have this surface here, how would I get that into the other script that we worked with? How would I panelize that? Like if, as long as I've got a surface, I can panel it and I can play with the openings and I can play with the color, right? As long as I've generated that. There's a lot of that's like a really powerful thing. So now your brain's probably churning, right? You're thinking about high school math again, maybe some college math. You're like, okay, I remember that graphing calculator. I remember, right? All these are equations. It's different kinds of math that I have, that I'm like putting into the computer in order to create, different curves. And so there must be a way to get an equation um, into the computer so that I can make all those crazy, mathematical surfaces that I see. And you're right, it's absolutely possible. Like, because again, all we're doing is talking in numbers. So I'm gonna look at a script really quick that I've got. Um, in fact, yeah, here we go. Math surface. Yeah. All right. So real quick, you can basically, I'll take you through this. There is a component that will generate points, and it's just called a rectangular grid. You can also just take any points that you made. So we could take the like series component that we already used from the other one. As long as you have a grid of points, that's fine. And in fact, if you start with a grid of points, it might be this. This is nice because it's a parametric structure. And I'm just gonna illuminate the points here for a second. So those are the points. You can construct points, right? You can take things and you can make a point. I can say construct point. You can also deconstruct points. And what deconstruct points means is exactly what it sounds like. It's like, so here I take a number XYZ and I get a point. Here I can take a point and I will get and I'll flatten this here so you can see it. And I will get the X coordinate, the Y coordinate, and the Z coordinate for each one of those things. And that can be useful because, especially things like the z coordinate might be really important information. Like that's how high something is. That's how tall something is, right? Um, so you can always get data in and you can always get data out. So you can go from numbers to points and you can get numbers from points. So what we do here is like the surface equations that you'll frequently find, and you can just find these online. Like you can just Google like mathematical surfaces. You go to Wolfram Alpha. That's Wolfram Alpha, Wolfram Alpha Alpha, and that's a computational like website. It's a computational search engine, and there's all manner of surfaces and things that you can get equations for. It's really really powerful, and I encourage you to check it out. But anyway, so you can we have this grid, and that most of the surface equations are in terms of x and y. So if you plug in values for x and y, you will get a value z. And in this case, I have like this saddle like equation. And that saddle equation would come from Wolfram, like Wolfram Math World, Wolfram Alpha. This is a monkey saddle, and I gotta zoom in here. The equation for the monkey saddle, z equals x times x squared minus 3 y squared. And what you can do is basically just transfer the x. So, x to the third minus 3 times x times y squared gives you like the monkey saddle. And there's all kinds of different things here. Don't worry about the rest of this. But what you do is this is called an expression component. An expression's awesome because basically you can do any formula that you could graph. It's really really powerful. You can even add different variables to it. But basically, you can take any variable, you plug it in, and then run math on it, and then you get math out. And so we have x and y from the grid, and the equation. So if you look at the monkey saddle equation, you've got stuff like oops, I lost my thing here. You've got stuff like darn it, like x squared or x to the third. So in order to express that, you're just going to do x to the third power, which is you do a caret, which is you hold shift and it's 6. Okay, shift 6 gives you a caret, that little pointy thing. So x caret 3 is x to the power 3 minus 3 times x. The times is a asterisk. X times y, caret 2. Okay. So again, powers are just caret and then the number, and then times is this star, and that's shift 8, right? Asterisk. To divide, you just go slash. Okay, and it'll tell you if it's gonna work or not. Like that slash does not like. It's like invalid expression, so don't mess with that. You've got all these operators here that you can play with, fractions, different kinds of matrix algebra, more stuff than you could ever really need. You can also use parentheses if you want to. And if you go here, there's a whole list of things. Like if you want to do cosines, tangents, there's functions for distance that are built in. You can use pi if you just type in pi. Crazy number of things. Very, very powerful. I will not cover it all, obviously, but most formulas that you can find, like for example, if you did some kind of structural calculation or some kind of optimization, you could actually just run it like right in the expression designer. It's very powerful. Okay. If you do that, so you plug in x and y, you get your formula, you get your z, you're going to get a very, very large number because look at all these powers and stuff like that. So what I did is I did this like sort of like division slider, and I made a very, very large number. And you can see the higher the number, the flatter it's actually going to get. So I'm kind of taking some of that out of there. I'm going to go ahead and hide all this stuff. It's getting in my way. So we've got our x and y. We just take those numbers. We're going to construct a point x to x, y to y. Z is where the fun stuff happens. We're going to make polylines. It's a polyline tool. Plug that in for our loft, and you got a mathematical surface. So something fun you could do, because I know you like to have fun, will be to go to Wolfram or some other thing and look up different kinds of surfaces. And it might be something where like you go to Google and you find a list of mathematical surfaces, or you find an image of a surface, and then go ahead and type that in to Wolfram to get the equation for it, and like give that a shot, okay? And then try to translate that into some math. You may need to adjust something like this. This is not always going to be the same case because you kind of have to use your head. Remember, use the panel component to kind of give yourself a sense of like what's actually inside of that data. You can see the numbers already get very, very large, and that's your clue that you need to do something with them. Always a good idea to have a panel so you can kind of see what's going on. But again, once you've got a surface, right, you could put that into the other script that I gave you, the mathematical, well, the surface paneling demo, and you can play with that. You can get a lot of variability, um, like out of that. Um, anyway, that's probably a good place to stop for today. So again, the lessons of the day, you guys to think about different ways of getting numbers into these systems. We talked about the number object, number sliders. We talked about panels, right? How powerful panels are. Series, range, and then modifying those numbers, right? Basic operators like addition and multiplication. The GraphMapper as a way to change those as well. And then lastly, the expression designer is a way to do really complicated formulas. From there, sorry, I skipped around here. From there, we just have construct points, curves to loft. Okay, we use the panel to visualize numbers to see what's going on. We talked about the difference between grafting data to create structures, and then also flattening it to get rid of those structures. Lots of different ways to build that surface, right? So really taking like basically pure numbers and building a surface. And then like as you've seen, once you have a surface, there's all kinds of things you can do with it. Yeah, so I think that's a good place to start to stop for today. Next time we're going to be looking at curves a lot more closely, and we're going to be looking at finding points along a curve, right? And yeah, I'll see you next time.